Ready to rumble?
Go.
Yeah.
All right, so my name is Roberto Hernandez. I work at Excella Consulting, wearing the blue shirt, I guess. And by trade, I'm a .NET developer and architect. I am very passionate about the code that I write. And as a consultant, I get to see all different types of code. I mean, I have done a lot of greenfield projects where I get to play with the latest and the greatest. Those are the best. Or I get to work in brownfield projects where we'll call it to basically either rescue a solution or basically modify an existing solution, which is the hardest part of the job, because basically we walk in with no knowledge in the door, have to acquire basic business knowledge about the different processes the solution is trying to solve, and then come in and save the day. So the presentation that I'm about to do is about that second type of engagements that we usually have to do as consultants, or even within the realm of our own company if we work for a specific company. And it's called Working Effectively with Legacy Code. For those of you that are not familiar with the title, I mean, everything is based off this wonderful book by Michael Feathers, which has been highlighted a couple of times today, which is called Working Effectively with Legacy Code. Even if you don't work with legacy code, we all do. It is an amazing read. It is an excellent book that will take you on an adventure on refactoring and learning basically how to make your code better. So, what is legacy code? Let's throw a couple of definitions out there. So, Ed already threw a slide on the board and said legacy code must die. And that's basically the feeling that all developers have when they encounter legacy code. But what really makes it legacy? Usually we're talking about code that is very poorly architected. There's not a single vision on how, we'll tackle that later. There's not a single vision on how the code should be structured. There's usually very poor or non-existing coding styles within the project. And there's either non-existing documentation or, my favorite, the mythical documentation. Have you ever walked into a room and asked, okay, how does this feature work? And everybody in the room was, no, that's Mike's territory. Nobody touches that. And then you ask Mike and says, well, we started working that on ages ago, but I'm not sure how it works. There's always that part of the project that nobody really wants to go into. But the definition that most fits Michael Feathers' idea about what is legacy code, it's code that's basically not tested. So if you're writing code today that doesn't have a unit test or that has very minimal test coverage, odds are you are writing legacy code. And why is legacy code so important to us? Because there's a basic fact about legacy code that goes beyond the aspect of coding, which is legacy code does not become legacy code unless it is extremely valuable, unless it is providing a business value to the customer. So the code may be ugly, there may not be a unified vision, but probably the consensus from the consumers is that it works. And we want new features, we want new capabilities on that code, so it is extremely valuable. Only successful code can become legacy code. Regretful piece of truth there. So now that we know what legacy code is, what are we going to do about it? Well, let's see what are we going to be basically going on a journey right now. Well, we already know what legacy code is, so let's talk about how does a code become legacy. We're also going to be talking about what are the different reasons to work with legacy code. And from that point on, we'll make a decision, philosophical, spiritual decision, about what are my options as a developer when I'm facing legacy code. And I'm going to assume that you guys are going to make the decision of go ahead, be brave, and face the legacy code, embrace it, and move forward. So at that point, I'm going to teach you a few couple of techniques. There are thousands of techniques in Michael Feathers' work about how to deal with legacy code. So let's start cooking. So how does code become legacy? Well, there are a couple of different ways. We already said that the code does not have a unified vision and architecture. So this can happen in many different ways. One of them is if there's a lot of turnover on the team. If there hasn't been a single developer, a single team that has worked on a piece of code base, odds are it's going to go out of shape. It's not going to have an easy way to work. Another way, if there's a large development team, and again, there isn't a unified vision how to work with the code base, so there's multiple styles of code, code duplication everywhere, and it becomes very hard code to work. And the last one, and this goes to, we are the ones to blame for the last one, poor team communication. When we're working on a team and there's not really communication among the developers, and there's not really a unified vision how we're going to take this product to market by providing a value by our code, obviously the obvious path is that the code is going to degrade and it's going to become legacy rather quickly. So, we already said that the code is valuable. So what are the reasons we go back into that code? Well, what are the reasons we code? Basically because there exists change. So, the product owners, the customers are going to want to add a new feature. They're going to want to fix a bug within that code. We as developers might look at it as a challenge and say, we want to refactor this code base. We want to make it a better code base. So that's a third reason, that one's on us. And the last one, we might want to optimize the performance of this code base. It might work, but it might not be the performance metrics that should go around it. So each one of these different 4 changes that we can perform on the code base affects the code in 4 different ways. When we're making changes to the code, we're probably modifying its structure when we try to add a new feature. We're probably modifying the existing functionality and the new functionality. Or we might affect the performance of the system overall. What I'm trying to say is that in each one of these different approaches, like if we want to add a feature, if we want to fix a bug, if we want to refactor or optimize the application, we are definitely creating risk. And going back to the definition of legacy code, since our application is not tested, it's a lot of risk. So what are my options? Yeah. How many of you have done the first one? Anybody? Show of hands? Yeah, look for a new job. Well, sometimes we have that choice. The second one, I've been involved in many projects where we've gone that route. We just looked at the code base and decided, no, this is too much of a hassle. Let's basically start from scratch. Let's build a new application, something new and shiny. But then we start going in this race of basically creating a new application that it's going to provide all the benefits of the original legacy code, and it's going to be easier to maintain. But there's always this race where the customer wants new features in the old one, so there's work done in the old one, and then we have to commit to do time on the new one, and there's this never-ending race that actually rarely comes out okay. So that's what I call the big bang approach, which is just throw it all out the window, start refactoring. Rarely works out as it should. The last one, and this one involves probably me a lot of the time, which is have somebody else do the job. If you can, why not use some of your money and maybe bring some of the original team members that created the technical debt and have them have a go at the project. Or bring in some consultants. Yeah. And have them work with that legacy code that you do not want to touch. Yeah. So, this is the option that I hope you embrace. Deal with it. It's a fact of life. In fact, one of the things that I said at the beginning is that we might be writing legacy code as we speak. I don't know if you guys have your laptop out, but some of you might be doing it right now. So legacy code is not really about the age of the code. It's about its maintainability. And how do we create maintainability? Usually by testing, providing coverage of the functionality in our application. So, you guys have decided to deal with it. We are committed, we're going to tackle this solution, we're going to work in our legacy code. So what's the industry standard? The industry standard is edit and pray. And it sounds worse than it is. Edit and pray, it's a bit more involved than that. Now, what I'm talking about is basically, if we got to add a new feature to our product, we go to our product, we identify where we're going to make our changes. We have a we have some knowledge of what our application does. So we tweak a line here, tweak a line there, and as developers, we walk through our application and the UI, try to find if we broke anything, then just push it over the fence. And have the QA people at that point, the QA testers who are working in that traditional environment, basically do the same thing, poke through the application, see if anything is broken, and then they themselves throw it over the fence. And at that point, the customer maybe can decide, is it really working? Were the changes implemented correctly? And that's the pray part of the equation. I mean, we cannot guarantee that what we're delivering works as expected, or that we haven't broken any of the existing functionality when we're using the edit and pray method, which is obviously the industry standard. Not going to argue against that. It's I've definitely been part of it. The last one, and it's what embodies the philosophy in this book, is cover and modify. We have already talked a lot about unit testing this morning. We have already talked about continuous integration. We have already talked about continuous delivery. And Ed gave a presentation which slightly talked on cleaning up your code, making it legible, etc. So that's what we should try to bring into our application, into our legacy code. And the way we do this, oops, skip that one. It's obviously by building a safety net of tests. Now, the major dilemma with working with cover and modify an existing legacy code is that we want to write code so we can modify our legacy code, but we gotta modify our code so we can write unit tests or tests in general against our legacy code. So there's sort of like a catch-22 there. So we want to write tests so we can modify our code, but we need to modify our code so we can test. Yeah, it's a bit of a conundrum. But again, we're trying to move the application from a state of flux into a stability so that we can actually make changes in competence. So cover and modify. It's all about building a safety of unit tests, higher level testing, similar to what Stephen and Rebecca did this morning with their automated tests using, in their case they were using Cucumber. I'm a .NET developer, so I'm more in the spectral kind of realm, but when I'm talking about high level tests, I'm talking about integration, I'm talking about tests that basically run against the basic UI of your app, if needed. But the focus should be on building a solid unit test base. So, step by step, cover and modify, introduce unit tests to our code base. And I believe that the phrase first was thrown around this morning, and I'll probably mess it up. When talking about TDD and writing unit tests, we're talking about tests that are fast, isolated, self-reliable, self-verifiable. Yeah, you in the corner. R, they're rapid, and T, they're timely, just in time. So we're writing codes against legacy code, so they cannot be timely. We've already broken that part of the equation. But we do want to keep faithful to the part of being fast. They have to be fast because when we're making additional changes to our legacy code, we want to be able to run our unit tests and get immediate feedback. You want them to be isolated. You want them to be able to localize your problems easily. And of course, if it's going to be a unit test, it cannot talk to a database, it cannot go over a network, it cannot rely on local resources, and like we said, self-verifiable, you should not need to modify any configuration changes for them to work. Challenges, I know. So this is sort of like a high-level plan on how you should tackle legacy code changes. Identify the point in your code base where you basically have to make your changes. Define which tests you want to run. Break the dependencies that exist within those areas. Write tests and make your changes. Feel happy about it. Now the assumption is, and I believe the whole book runs on that assumption that we're using high-level languages. What I mean by high-level languages is we're using languages that are going to allow you to basically work through this flow by using maybe object-oriented programming techniques or any of the agnostic-oriented programming techniques that languages like Java or C# support. Sensing and separation. We're going to have a demo on sensing and separation, so I don't want to go too deep on it because I'm going to try to showcase it by example. But sensing and separation will be key to the first part of the equation, which is identify the chain points and identify which dependencies we need to break. So we go into our code and we try to sense which dependency we need to break in order to test this functionality. Classical examples of dependencies that need to be broken in order to test something. Well, if you have a connection to a database within the flow of your business logic, that's a short bet that you're going to have to refactor that out. If you're writing to a specific hardware device, maybe the console out, which is something I'll use later on, or anything else in particular, then you need to break that out. And then comes the art of separation. We need to establish separation from those dependencies so we can actually do or test it. One of the tools used constantly for this is fake collaborators. Now, fake collaborators are just objects that impersonate the functionality of your application. And by that I mean the dependencies. So if I was writing code that read from a database, I may implement a fake collaborator to read from the database. And let me do a bit of demo on this one. And I'll try to follow the terminology as closely as possible and try not to lower my voice as I do. And try not to lose the projector. Okay, this is legacy code. I wrote it, I believe, 2 nights ago, but still, it's legacy code. It's a very simple app. All that is saying is, telling me is enter a message. I'm going to enter my name. And when I click enter, it just echoes my name. Why is it legacy code? Well, it's not tested. And when I look at the code base, and I'll show you the class that is going to be the target of all this refactoring, there is not really a good way to test this. Why? Because I've tied the logic of my application to the framework and the resources that it's using. And this is a very simple example. The only real, if I go through this method and I try to sense which dependencies I need to establish separation from, it's basically the console. I cannot, with the tools I'm going to try to use for testing, basically validate the information that's getting dumped into the console directly. So I need to establish some separation from that. So, one of the easiest way to do this, and it's actually one of the recommendations of the book, is actually splitting the functionality of your app into different methods so that you can split those hard dependencies out. So, I'm going to do that right now. In fact, I'll be more annoying about it. Let me write a test. And I'm using NUnit, so I'm using a very basic test platform. Thank you, Stephen. So stealing a bit of Margar's territory, what I'm going to do here is, if I'm going to test that class, I probably want to test it basically doing, hey, give me a new echo console. Why is that not working? Because I'm not in the method. And let's say what I want to verify is that the echo method outputs expected response. Now the add part of the equation is always going to be echo, and let's add something here. I'm not very self-centered. It may seem like it. I'll use my daughter's name. And assert. See, here's where the problem is at. What am I really going to assert? Because again, I don't have output to what the console is doing right now. So there's not really an easy way for us to break that dependency and investigate what's happened. So even though what I want to do is basically verify that Dad, Roberto Hernandez, my daughter's name, is being output to the console, there's no really good way to do that. So again, exposing methods for functionality, specifically for testing, when working with traditional TDD, the one where you're working in green fields, is frowned upon. Because at that point, you're working on a new design, it should be muddied by things like that. But in this case, we are working with legacy code that is hard to work with, so we can have some flexibility in terms of how we implement this. So let's say I wanted to abstract away the functionality for console line. So one of the ways I could do this is write a method that can be overwritten by an implementation that hides that console write line. So let's do that. Let's say and let's just call the console write line method at this point. So again, I haven't really done anything too scary. Question, how many of you are .NET developers? Just curious about that. Well, a good number. Java developers? The rest? Okay, so you guys probably get what I'm doing. I'm just trying to figure out if I have to go a bit, explain a bit of the language construct. So let me see. One thing I haven't done here, I haven't met this method virtual. Let's do that. So now that I have this class isolated, here is where the business logic is going to be at. And when you see the change, it's going to make a little bit more sense. But now I have the console write line isolated here, so I can basically override this class within my test environment to test the business functionality. So going back to my test class, I'm just going to create a class here. And I'm going to give it a name that rings correct to me. I'm going to call it system under test. And this is going to inherit from the echo console. At this point, I will override that console write line. And instead of outputting to the console, I'm going to create a property, type string. Let's call it last line. And what I'm going to do is, when that method is called, assign that value. So I've already exposed the functionality that is getting sent out to the console. Now I just need to validate it. So I'm going to substitute a couple of things here. Instead of going to the echo console, I'm going to instantiate my system under test class. And I'm just going to go ahead and assert that, or are equals to use the Sainer construct. And we have expected actual, so I expect the response to be this. And how do I check it? By evaluating that last line property. So it's just a trick of the trade. The way this is called within the how Michael Feather calls it, let's put it that way. We're basically creating a scene, so we can basically do testing on code that currently was untestable. So let me run this test just to see if it passes. Okay, so that seems to work. So the reason why we went through this whole exercise of basically isolating what was business, what was not, and again, this is a very concrete example, very small, but let's say that the business now comes up with a requirement for the second console that every time there's an output, it has to be prefixed by the word name, semicolon, or column, whatever. So if that's the case, then we probably have to write tests to accommodate that. But now that we went through all this trouble, we could probably do things like that. We could go echo output is prefixed correctly. And again, I'll steal some of this code. Let's say it's not under test, and assert it. So I am going to change this to an assert that just because it's going to be a bit more friendly to what I want to accomplish, which is assert that the echo last line is a string that's starting with name. So that's the new business requirement. As simple as that.
Can you blow up that text a little bit, larger font, please?
Which part?
There you go. That's good.
There we go. So this also I'm going to refactor because now, well, I know that it's not going to pass. I should run it, but let's say this one should be an assert that a string containing, and I have a problem there. And let's do the echo last line. There we go.
2 Z's. How many Z's in Hernandez?
Depends on the country. Okay, so we have both tests. Let me run them. Okay, one of them still passes. I mean, I haven't changed a lot of the functionality, so I'll just go back to my class and I'll just add that. Now I'm gonna tools of the trade. I'm using Resharper. Let me try to do this a fancy way. If not, won't waste that much time. So let's say that this is now going to be, and that's passing the message that's incoming.
You put a semicolon after me.
Okay.
Name as a semicolon.
Well, we wanted a red test, right? Okay. So anyway, we took what was untestable when we started, and now it's testable. And again, it's a very small example, but you'd be surprised how much mileage you get about using methods to basically allow, again, seam access to your classes where you can modify the existing dependencies. Now I'm going to take this a step further with the Echo console, because I also want to show you the more professional approach. But the more professional approach, sometimes you cannot do it, which is basically, we broke the dependency successfully by using this method, but sometimes it's better to go all the way. And let's do that. Let's say we have this Echo console. So the more professional approach would be to extract the functionality of that console.write line. Why? Because right now we're outputting to the console, but there could be a change of requirements. It said that instead of outputting to the console, we're outputting straight to the printer, we're outputting straight to an email, if that's one of the requirements that our product owners even thinks up. So really, we don't want to have still this dependency embedded in here. So one of the things that you should actually do, and this is actually a way we could do it, it is described in this book as, and I'm probably going to kill this, primitivizing your, probably not a word either, but primitivizing your dependencies. In this case, console is our dependency. So we're just going to do the following. Introduce a new concept to my application called the writer. Now, I'm going to make this an interface, and sorry for the Java guys, but I'll put an I. And let's just have a write line here. Now, an implementation of that interface could be a console writer. which implements that iWriter. So in this case, we're deeply into the refactoring phase. Let's have Resharper help me out a bit. There's our method, and yes, console right line. And let's say, scratch this. We'll be back to that. I want to first use the one that the system provides, which is TextWriter. It'll be easier for us to implement at that point. And this technique is called poor man's dependency injection. I'm just going to create two constructors, one calls the other, and the first one is actually going to have the hard-coded final dependency. And there we go. So now, here we could do something like writer write line. And in fact, there's very little purpose of having this method anymore since we have already abstracted it away. It's going to be a lot cleaner. Let me just take it out and just do that. So, just to show you what this looks like from the application that's consuming this, I mean, we don't want to break the functionality of the existing program. So here, it still looks exactly the same, and if I run this, still should behave exactly the same, hopefully. Yeah, everything looks the same. So we've only improved the code a little by throwing a bit of patterns at it. We've improved our collaborator. Right now, we don't need a collaborator that's so strongly tied because we've brought our console out into its primitive form, in this case a text writer, and we're going to try to basically work with this in the other side of the equation. Let's go back to the tests, and for fun, let's kill this. So our test is now cleaner. We don't need to inherit from anything, and let's replace all this with the straight up echo console. So one other thing that you'll notice is that I now have the ability to provide a writer. And what I can do for now, is say that the writer that I'm going to be using, which is, in this case, it's my fake collaborator. Let's do a string writer. And let's pass that in. So now the evaluation is fake to string. Same thing in the second method. So this is a more professional work because, again, we're not inheriting, we're not creating that much additional code. We've actually just looked at the Echo Console class and actually refactored the dependency using a proper pattern of dependency injection. I believe that if I run this, which should be pretty close to green, yeah, we're green. So again, that's just one of the ways. I wanted to do this one, which is basically primitivize the dependency rather than make the complete collaborator before we moved on. Just because I wanted to showcase that, yes, sometimes the .NET framework, or if you guys are using your JVM, I don't want to call them libraries, whatever you call them, that there are ways built into the frameworks to actually solve some of these issues. So I'll go back to my Echo Console and take it a step further. Why would I take it a step further? Well, in this case, TextWriter does not allow the flexibility that I was quoting before, which is if I want to send this output to, again, the screen, a printer, email, and just keep this code as is, I cannot do that with the TextWriter. And that's when something like implementing an abstraction over the dependency will come in handy. So let's just go ahead and do that. Again, void, right line, and let's just say a string message. Oops. Let's implement that writer as a console writer. And let's just here do the console.WriteLine. As is. So now what I'm going to do, go back to my Echo Console class. I'm still in refactoring mode. And instead of providing this guy, I'm going to go ahead and say new console writer. Now this is going to be of type iWriter and type iWriter. So my refactoring is good. Now I need to go make sure my tests pass. I'll go back to my tests. And here's where I'll throw another tool at it. You've seen me use Resharper, Alt-Enter, move things around, refactor. But another tool that we can actually use to break some of these dependencies for testability purpose, it's a mocking framework. And I'm going to throw one in, mock Q in this case. There I have the reference. And now I'm going to say that my fake it's going to be a mock of iWriter. And
No friends. It's just a property.
thanks. And this goes away. Now what we're going to do is basically using the mock, let's say, verify that the writer was called, its WriteLine method was called, and the parameter and sorry for you not to reach up, guys. I mean, this is going to be a bit of an interesting Lambda. But let's say it is a string, and that string should be equals to name. And we're going to say that this, same parameter, happens once. So, to those of you not familiar with Lambda statements, I mean, I'm not going too crazy here. All that I'm saying is verify that the method was called, so I'm basically inspecting for behavior, and verify that when it was called, that this parameter is set with the value name is out Hernandez. Now, I went a bit overboard because I set the full value, but I guess I can live with that for the demo purposes. So in case of the next one, I'm gonna steal a bit of the code. I never do this, I swear. I always write my code, never copy paste it. I'm gonna do the same thing, but instead, in this case, I'm only validating the prefix. So I'm gonna say starts with that. Lambdas are great, but sometimes you fall into this, where's my parenthesis mode? It drives you a bit crazy. But again, this is more of a professional solution just because we are abstracting the dependency completely from the original test class, and we sometimes can do that. I actually have found, and this is more like an experience every day-to-day activity, that you get more mileage when you're working with a legacy system out of trying to do the little things, like pulling out those methods into testable buckets and just hitting the easy targets rather than going out for the full refactor approach. The full refactor approach, you leave yourself a bit more open to breaking the whole application, which doesn't happen in this case because, again, it's a very small line. So, back to here. So I actually cheated a bit because I went a bit into this topic, which is seams. Because it's very hard to talk about working with legacy code without talking about enabling seams. So when you enable a seam, you're basically opening a way to modify the dependency of your application without modifying its behavior. In the first example, we actually did it by creating a method override, which was very efficient. In the second example, we actually went a bit further and said, hey, let's refactor this guy, let's take out the dependency, let's bring in dependency injection into the mix. So all that we're doing while we're working with seams is we identify the dependency and are enabling a point for, again, modifying the dependency without having to modify the behavior of the code. The easiest way, again, there are places where we can actually see this in legacy code, and some of them are really hard to break. I'm going to go straight into the second demo. Again, I stole some of the seam demo for Echo Console, so I'm going to go straight into that final fake data reader demo because it's a very common one. So this is the same app. This is actually an Echo Console also of sorts. Because all this app is doing is basically reading the information in the table and dumping it to the console. So the first challenge obviously will be, if we were doing the sensing part, like which dependency do we need to break to actually work with this code, is, oh, of course, let's break the console one, which we already know there are many different ways to do it. The other one, and this is probably the one that would make us more uncomfortable at first glance, is all the different SQL stuff. Like SQL connection, SQL command, SQL execute reader. Does this even run? Let's see. Hopefully it does. Maybe not. Oh well, it does. So again, nothing fancy. It's just outputting those names out to the console as it finds them in the database. But of course, we don't want to touch the database when we're unit testing. So if there was a requirement to add a suffix to this that was basically add a date to each row as we're outputting to the console, we wouldn't be able to test that if it was a feature that our product owners requested. So I'm going to do the simple one first. I'm just going to use the going to expose the method again. Let's see, protected, virtual, in this case void, right line. And let's passing a message. So console.writeLine. There it is. So this dependency can now be broken by just doing this. And string.format, that thing. The second dependency is a bit more complex, because even though we have a connection object, even though we have a command, even though we have a reader, all our code depends on is on that data reader. Hopefully you don't see many code like this, code bases like this in your life, but let's say you needed to do this. Well, let's start doing the same thing, but let's focus on abstracting the data reader. And let's call this just get reader. So I'm going to do some flexible copy pasting here. A lot of things that were in there that were not really business. And I guess that would be it. Copy this guy up. So same code base, a bit different flow, returning a reader, it's a night data reader. And now all this code down here is going to do is call the this.getReader. So again, using the simple extraction method, we have accomplished a lot. We now can test both the console.write functionality or using that or all that database functionality that's on the top. So let me just do this real quickly. I know that we're running out of time and it is Friday, but let's go ahead and just bring out what I need. Let's write a simple test. Let's call it read data test. Let's do a read data outputs expected response. Add a test argument. And unit again for testing purposes. So my triple A side equation, what do I want to do? I want that system under test, and I'm going to test it in the following manner. And I'm going to assert that the information that's output to the console is the name I expect. So by that I'm verifying that the reader works as expected. I'm verifying that the console write line works as expected. So I do have to use the same technique I used before, in the sense that I have to create, and I'll use a shorter name this time, a system under test class, which inherits from read data, that would allow me to do things like the following, which is override the write line, and it seems like I missed an override. This method should also be protected virtual, and I should also override the get reader. So I don't want to write all the code to do this. There are resources out there on the internet on how to tackle hard dependencies like this ones. I'm just going to add some libraries that I already have on my computer that will help me out stub databases. So let's see. There we go. So instead of returning the straight up line, what I'm going to do is create a last line method property and assign the message. Let's make that an auto property. And for the data reader, instead of going straight to the default implementation, let's just say that I'm going to have a set of information. Stub. There we go. So I'm going to create that data set, and it's going to have a result with a single column name, which is what our code is expecting. And that result is going to have a single row. I'm going to just inline it for efficiency with my name on it. And let's just return that reader. Now, all that I need to do here is verify that the last line, and I'm not going to get it because I'm not on the system under test, is equals to my name. Or just to verify that I'm doing this correctly, there's I am outputting the name, but I'm doing it with a prefix. So I'm just going to say insert that, last line is a string containing my name. The point again that I'm trying to make is that even hard dependencies like this one, where we're basically talking about abstracting away a data reader, which is one of the main concerns architects have when they look at a code base, like why is their database code intermingled with the business logic? It's something that can be accomplished, and again, it can be accomplished using very simple techniques like identifying what the dependency is, extracting the method, creating the scene that we're going to use basically to overcome that dependency, and basically test it out. Don't skim on the tools. The tools are basically going to be your savior when you're trying to create coverage for your existing legacy code. You want to know how much it is, so tools like ncover, .cover, or xcover will help you track what amount of your legacy code base you're actually targeting with your new test, your new coverage. Tools like NUnit will allow you to run the unit test, as does MSTest. And tools like Resharper will allow you to do extreme refactoring of your code base. So the message from this is, skim through here, is that there isn't really a silver bullet to deal with legacy code. There are just techniques, which are actually refactoring techniques on how to minimize the impact of breaking your dependencies in your code. Most of them are outlined in the work by microservices working effectively with legacy code. And again, it may be overwhelming at first. You may want to yank your hair out of your skull or run into a moving bus, but please don't do that. Just be pragmatic, and as the number of tests that's targeting your legacy code increase, it will get better. You will see that light in the end of the tunnel. So thank you for listening, and if you guys want the code for my presentation, it's all available here, including the slides. So thank you. And again, if you have questions, I'm here for you guys.